Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. The average of 5 distinct positive non-zero integers is 50. What is the difference between the maximum and minimum possible values of the largest of these 5 integers? We start with this ordered representation of the 5 positive non-zero integers, and let them be a1, a2, a3, a4, and a5 as arranged in an ascending order, meaning that we have a5 greater than a4, a4 greater than a3, a3 greater than a2, and a1 greater than a2. So the values increase as we go from a1 to a2 to a3, and the largest one, of course, is a5 in this particular sequence. So now we have to basically consider how can we get the maximum value of a5. So a5 is already the largest of those 5 numbers, but here we are talking about the maximum possible value. And the only way we can get the maximum possible value of a5 is if we minimize the other 4. So this problem is equivalent to finding the situation when a1 through a4 will take their minimum possible value. And that is actually pretty simple, because we know that it's given that these are positive non-zero integers. So the least value that a1 can take is 1, and these are also distinct integers. So distinct means that they're all different. So the least possible set of values that a1 through a4 can take is, we'll start with 1, which is the least possible one for a1, and then a2 can take the next available value, which is 2, and a3 can take the next available value after 2, which is 3, and in so way a4 can take the value of 4. So this is important to keep in mind, that the problem specifies that these integers have to be distinct, right? So they cannot take on the same value. So when you're assigning the minimum possible values of these integers from a1 through a4, of course a1 being the least possible integer value, and then that's 1, and then we look for what's next. What's the next lowest possible value after 1? So that's what we assign to a2, and so on to a3 and a4. And once we do that, remember their averages still got to be 50, right? So we can take their sum, and this is the situation when a5 will get the max possible value. So 1 plus 2 plus 3 plus 4 plus whatever the max value of a5 is, divided by 5, that still got to be 50, because the average of these numbers is 50. And then we just solve for the max possible value of a5. So we have 10 plus max possible a5 comes to 250, and from this we get the max possible value of a5 as 240. So next we'll consider the other end of the spectrum, which is the minimum value of a5. This is the minimum possible value. And remember, a5 is still the largest of those 5, right? We're just finding the minimum possible value of a5. And the strategy there seems to be finding a way we can maximize a1 through a4, right? So if a1 through a4 is maximized, then we can probably find what minimum possible value a5 can take. And how do we maximize a1 through a4? Well, we can make them as close as possible to the average, right? Remember, this is still the ordered representation of those integers. So we have still this ascending order a1 through a5, and here we are trying to maximize what values a1 through a4 can possibly take. And the only way to do that is to make them as close as possible to 50. So if we take the center value a3 as 50, and then you can start stepping down from there. So a2 becomes 49, a1 becomes 48. And on the other side, we have a4 is equal to 51. So this still ensures that all of these integers from a1 through a4 are distinct, and they're now tightly concentrated around the average value. And in this case, in order to make the average 50, a5 got to be 52, which is the minimum possible value of a5. So the minimum possible value of a5 is 52. And then we consider the difference between the maximum and the minimum values of a5. We take the difference, and that comes to 240 minus 52, which is 188. So the correct choice in this case will be option D, 188.